Hello everyone, my name is Matt Heater, and today I'm going to be talking about an experiment that I performed in my environmental science class. The title of my experiment was Sand Content of Soil versus Weed Germination and Early Growth. Basically, probably wondering how this is important to me as someone that's not involved in the agricultural business. Wheat is one of the top grains that are used around the world today. You can find wheat in forms of flour or the grain used in cereals or other breakfast foods. So the purpose of my experiment was to determine whether sand has an effect a direct effect on wheat growth in the soil, and also what would be an optimum sand to soil ratio to get the best growth of wheat. So before I started an experiment or conducted one, I asked myself a question of, does the amount of sand in the soil have a direct effect on wheat growth? Researched this a little bit, tried to find other people that had similar studies to see if they had any inside information to start with. And according to Marquez Basso, he's an agricultural agronomist, he answered yes to that question that I asked. And he actually said that sandy soil can be helpful if you have a mixture of other soils, which will help cause aeration, drainage, and easy passage for the roots to go through the soil. In contrast to that, I found someone else who believed differently. Casaban, who is another agronomist, he said that soil can cause too much drainage, making the soil dry and lose all the nutrients. So there's both ends of the spectrum, and so basically I wanted to test it myself and see if I could find results. So before I started, I came up with a hypothesis, and I said that my control group, which had no sand in the soil, would have the best growth. I believed that the sand would be not helpful at all. So basically, I had 5 concentrations of soil. From left to right, you can see the control, level 1, level 2, level 3, and level 4. 5 concentrations with 3 pots in each to get rid of any bias. If I only used one of each level, I could throw it off. In the control group, there's obviously no sand at all. There was 750 milliliters of peat soil and no sand. The first level there had 650 milliliters of soil and 100 milliliters of sand. Level 2 had 550 milliliters of soil and 200 milliliters of sand. Level 3 had 450 milliliters of soil, 300 milliliters of sand. And finally, level 4 had 350 milliliters of soil and 400 milliliters of sand. We watered the plants with 250 milliliters of water every 2 days. Kept them all in the same section every day, did not move them, so there wouldn't be any chance of different sunlight on one day or whatever. We kept everything consistent. After the 2 weeks of testing that we measured the length of each stem that the seeds produced, after the 2 weeks, we pulled the plants from the pots and measured their full entire length with the roots, and the results were recorded. This picture is actually taken just before that we pulled the roots out. So my results from my study were that level 3, which was the 450 milliliters of soil and 300 milliliters of sand, was the best ratio that we found. And the control was actually the least amount of growth. So this instantly proved my hypothesis wrong, but that's what the study was for, to test. After, also with another result, after 300 milliliters of sand was added, the results started to go backwards, and from the control all the way up, adding more sand was helpful, but after you reached the 300 milliliter mark of sand, that's when it started to go downhill and not grow as much. But findings can be useful, I believe, to farmers and other agricultural businesses around the world, because this is a small scale experiment, but move this up to a larger scale with an entire property or of an agricultural business, they can find the correct ratio of sand to help get optimal wheat growth. Thank you.